Work it, make it, do it, make sense.
We are ready. So who wants to sleep? Can raise their hands? I would like to sleep. Right? Okay, so good morning, and thank you for coming. So today we will, I don't know how much you ate yesterday in the night, but usually when you eat a lot, you cannot sleep very well. So you may have nightmares. Today we are going to talk about one of my nightmares, hoping that you are not going to live the same nightmare. Unfortunately, my nightmare was not during the night, but it was during the days, in the office, or not something that I would wish to everybody. But okay, shit happened. Sorry. So actually, one of the things that I want to say you is that whatever I'm gonna talk you today is the truth. Nothing else the truth. I know that there were moments where you will believe, no, that can't be true. It is. Unfortunately, it was. So even it's unbelievable, it's going to be all the truth. Quickly about myself. My name is Davide. Usually for English people, I prefer to be called David, just because many cannot pronounce my name, so David is much better. I have worked for different organizations, including United Nations and Oracle University, giving Java classes. So it's hard for me to say what is my job. Usually it's the worst question that you may ask me. So what I usually do is trying to innovate whatever I'm working and improve the environment, either culturally or technologically. To do that, usually I continue studying every month new topics. It's hard, but sometimes you can have a lot of rewards, not all the time. So starting looking about my work at the United Nations, we had to face a huge problem. So we have to deliver an application to rural countries where you may know if they have a computer, it's not something very fast. Maybe something that is still running on an AMD K6 or something like very slow. So one of the problem was to deliver something that could run on every computer, even when still Windows 95 or 98. If you don't believe me, there are some countries that are still using them. But they need them because with that software that we developed, they can get some loans from World Bank. But of course, if you're asking a mortgage, the bank wants you to return their money, sometimes with something more, some interests. It's not usually the aim of World Bank, but it may happen. So they want to check that everybody is using the money in the right way. To deliver that thing, we spent years to build the application and the installer and check that everything was working on all the operating systems. That was a nightmare, but it was a technological point of view. So we try to deliver the best that we can. The application is built in Java. At that time, Docker was not something that we could use because it didn't exist anymore, not yet. And to be honest, I would have loved to have Docker because a lot of times people were calling me, oh, this is not running, this is not installing. And then we found that there were different configuration, or at the beginning it was only running on Windows, so a different DLL, or Windows was blocking something else, or the firewall, other stuff. It was, at the beginning, a lot of time that the application seems not to work. And of course, the end user does not care why it's not working. He just wants the application to work. And many said, oh, but why you can't have an installer that does this stuff? Yeah, it's fine. If you have the latest version of Windows, we can do it. But if you're running Windows 95, the user may not have that feature. So it was hard for us to figure out how to have that application working on all the system. I had thousands of virtual machines with all the different configurations. Sometimes also, once we found that running the application on a Turkish machine was not working, because the script was doing some kind of crazy stuff, but assumed that the user was running an operating system in English. With Turkish, it's different, so the output is different, and we could not grab the information that we wanted. So let's start building other 6 machines for Turkish. Unfortunately, I couldn't use Docker. Lately, I switched to another company that was working with genomics. We were trying to change or to predict how the DNA can change and how to predict also how to cure, to fight some illness without actually doing experiments, but just looking into a large amount of data and then finding the right medicine that may cure something else. We had to work with a lot of data. And also we were building an application. At some point, some guy said, oh, you know, there is another application, there is another group that has built an application that is doing part of the things that we need. So actually, as I don't want to reinvent the wheel, I said, okay, yeah, let's look at that application. At that time, I was leading that group, so it was fine. We can save some resources. We can focus on what we really want to do. So we started looking at that application. And that time, I discovered Docker, because that application was using Docker. Fine. I said, oh, idea is fine. I just knew virtual machine, no Docker. But yeah, let's try. I never care about learning something new. So we started. I ran the commands that were in documentation, and it was not working. Docker was not compiling the image, so there were some problems. So I spoke with the developers. They were looking some stuff, but in the meantime, I was also building the image and doing the changes that I saw in the error log that were happening. So what was preventing building the image? At the time, I neither knew what was in the image. We will discover today. After spending some time, I made the image working. So that was how I was starting working with Docker. It was not easy. Actually, the way that they were building the image was not clean, but I could understand. It was at the beginning. They were still experimenting and developing the application, so their core focus was not Docker. That's fine, and that may happen. You may see some configuration of Docker. At the moment, I'm not using specific terms. How many of you already use Docker? Oh, cool. How many of you already built an image with Docker? Pretty cool. Okay, so when you are, for all the others, when you're building an image, actually, you have to build some instructions. We will see in details later some of those instructions. Sometimes you have to write few things. Some other times you have to write a lot of stuff. In that project, they were writing a lot of stuff. So it's like executing a bash script with a lot of information, left in hundreds of rows. It's not the best option because anybody that has to maintain that thing has to go through all those rows, must understand everything that you are doing. And if you are doing some hacks, they may not work every time, or maybe somebody that is just maintaining them or trying to change them may make some mistakes. So that can happen. That's fine. We will learn how to avoid those things. So how many of you, how many of us, is working in an agile environment? So yeah, actually, that's the point. Is it really agile, your environment? Who really believe that his working environment is agile? Cool, 2, 3, 4. No, that's not option. Okay, so almost everybody claim that they're working on agile, or they think that they're working on agile. They may be working on an agile. But it's if you are spending hours with your colleagues trying to define a feature or to decide why you missed some critical release, or everybody else believes that you're ready to release a new version, and maybe your boss says, no, we are not yet ready. Why? Because we haven't run that test. Maybe everybody else ran that test, or maybe it was his duty to do that test. But that may break your agile. So you come to the end of the sprint, if you're using sprints, and you can't release. So sometimes you are spending hours, so you have the impression that you're wasting time. And I would say you that it's definitely not agile if you end with monolith. Because then when you want to change even a little thing, you may spend hours, days, weeks, just to try to change a small thing. So I would say that we should have studied this in my previous project with genomics, because to me, monolith is something like an illness. We should be more small. When you're working with the monolith, usually you know just a single part of the whole application. It may work, it may not, or sometimes it works, but nobody else wants to change or update or even a library, because you don't know, maybe you fix that things and then you broke everything else. And most of the time, you don't have tests that check everything. So just it's running. That's maybe why you don't want to release quickly, because you want to test once, twice, 3 times, and then have somebody else to test, and then let it rest a while and see if it's still working. And if it's still working, maybe you are just doing a little step in production and say, oh, yeah, maybe it's working. But this is not the best thing. What I really love to do is to build something, deliver it, and never worry when it goes to production, nor if it's still running, because I want to be sure that everything is still running. And I don't really like when I hear, oh, my computer is working, oh, mine is not working, production is not working, QA is not working. So even if it's working on your computer, it's not enough. So that is when we can get to a point that we need an environment that we can reproduce. And that is why often you may have seen virtual machines. We will see them in this presentation as well. They may be fine, because then you have some environment that you can test and you can move, and it's working. It should continue to work. It's not always the case. So when you are working with a monolith, usually you go down in a spiral because you don't change something, or you just make an hack because you cannot change it in whatever you consider the proper way. You don't do that because you are scared that you may break everything. And of course, nobody wants to break everything. We try to survive. To be honest, I don't think that surviving is just the things that we should do. I believe that we should improve our environment, we should improve our application on a daily basis. Even a small change may help the application to improve, get something that we should be proud of having working with. How many of you are proud of the work that is working now? Okay, not too bad. I guess 5 people in the room, so it's usually there are less people, but that's fine. That's fine. We can go there. So what you may hear that is your application is complicated. Yeah, it's a monolith. It's complicated. Somebody can say that it's complex. It's just a little better than complicated. What I really love to hear, I never heard that application is easy. It just works. So how to get there? It's not a dream. We can have, well, it was a dream for me, but now that dream became true. So I want you to have the same dream, make it true. So when you are working usually with your application, you have to decide if you need more CPU or more disk storage or database storage. Unless your company has a very deep pockets, you have to decide something that is in the middle. You cannot have 1,000 CPU and unlimited disk space, because that will cost a lot. And even if your company has very deep pockets, probably they don't want to spend or waste so much money on such machine. And then if that breaks, you have to buy another one. So it's not the best investment that companies want to do. So you usually have to try to find an average or CPU or database that may help your application to run in the best way, smoothly, we can say. But so usually we cannot have everything that we want. But there is a light somewhere, because actually, if our application, if we can split our monolith in some part that is doing a lot of calculation, so just needs CPU and almost no disk space, another one that is just storing the data, we can have a lot of resources just CPU and a lot of resources just disk. That will be cheap, maintainable, and also we can add more resources as we need without having to buy another machine that may cost $1 million. But so how to do that? That's the tricky point. So we know that one size does not fit all. But what is the right size? That's hard to answer. You know, developing your application, you know if you need more CPU or more memory or more disk, more database, you know. But if you can split and having different machines that have the maximum of what you need on that machine, you can work smoothly. So you can achieve your task. So what we did before was using virtual machine. So let's look how virtualization works. How many of you didn't use the virtual machine? Okay, 1. Okay, 2. So we almost everybody know how virtual machines works. And actually, if we want to simplify that, a virtual machine is like a computer that has the system, the operative system, the applications, configuration, connection usually, and then on top of that virtual machine, the virtual computer, you are installing your application you're running. The benefit of virtual machine is that it's clonable, so you can copy it and move and install on many instances without having to rebuild everything. It's not hardware, so you don't have to move that thing to another center. It's cheaper, usually. You may have to buy a license, but it's fine. So how we build a virtual machine? We start from an hardware. So we have our bare metal where we are going to install something. That something is the operative system, as we usually do. And on top of that, we are installing a software that will allow us to run the virtual machine. On top of that software, we are installing another operative system because our application needs the operative system and cannot use the underlying operative system, not with the virtual machine. So you see something, you may see something weird. We will see that in detail later. And then on top of that operative system, you install whatever you need to have your application running. So at this stage, we have something like 5 layers. There may be some more, but let's stick with 5. How virtualization is different from the Docker environment? So actually, with Docker environment, we have hardware. That's fine. Same thing for virtual machine. We have an operative system. That's the same thing. And then we have small software that is called Docker. Is Docker a virtual machine? No, it's not. Is Docker an application running virtual machine? It's not. They are different. So on top of the Docker, that is an application that can run other stuff, and we call those other stuff images. An image is like, image is actually an immutable package. Immutable means that you can copy that everywhere you want, and it's going to work the same way every time that you run it. When you run it, the image, then it has been called container, because the container contains all the configuration and may contain all the data that you need to run your application. So far, if you see, we are still with 5 layers, but we have something more because we have more copies of our application, our image, actually now we know the term, that are may run everywhere. In the same machine, we can run multiple images, which we cannot do in the same virtual machine. Of course, on the same virtual environment, we can run multiple virtual machines, but we are kind of wasting resources. So what are the differences between virtual machine and Docker? They are both 5 layers, but if we will see in detail, you see, in the virtual machine, we have 2 operative systems. Sometimes they are the same, some other times they may be different, but we are wasting a lot of space in our machine. So even if you have an unlimited space, you are still wasting space. So why don't save that space? We can do that with Docker. Another thing that is important about Docker is that it's using the underlying kernel to do some stuff. So it's delegating a lot of stuff to the underlying kernel. That's very good because we don't have to install different kernels. We don't have to maintain a lot of stuff because in the virtual machine, you will have, at some point, you will have to upgrade that virtual machine to something else. Let's say that you are only working on Linux environment. That's fine. Now you want to upgrade the kernel. You have to upgrade, if you're working on a virtual machine, you have to upgrade maybe the host and all your virtual machine. That is a huge task. If you just want to upgrade the kernel on your Docker environment, you just upgrade the kernel on the Docker host, and that will work. And that change will be picked by all the container running on that machine. So you can save a lot of time, and also still. If it's working once, it's going to work every time. If it's not working once, it's not working on my computer, it's not going to work on any of your computers, that's good, because then we can avoid that people say, it's working on my computer. If it's working on your computer, it's fine. So let's get back to our monolith. We went to a point that we want to split the monolith in various microservices. I don't know how much experience you have with microservices. Nowadays, almost everybody is talking about microservices. It's something cool. Often you can hear microservices and Docker together. There is a reason why that happens, both because why you want to split microservices in monolith in microservices and why you are hearing about Docker. That's because with microservice, actually you're doing a single task the best way, using the most of the resources that you have, and using, well, sometimes all the resources that you have. So you can have a machine that has a lot of CPU for an application that is using a lot of CPU, and you can have another machine that has a lot of disk space because maybe it's your MySQL application. So let's say how we can build a microservice. We start from an operating system. That's fine. So we are building the microservice in a Docker image. So how we build that image? We define what is the operating system that we want to use. You may have tests on different systems. You may have your preferences. You may have a package that runs on that system. That's fine. You decide whatever it is. On top of that system, you are making your customization. So you're installing maybe more packages, maybe the package that you or another branch of your company has built, or is a dependency, is a library, or whatever it is. You can name them. In our case, maybe also yours, you are also installing Java, because your application is running Java. So let's add another layer that uses Java, configure Java the way that you want. So you decide the version, you may decide other libraries, dependencies, and also policies. Then we go to our service. So we can install our service on top of that Java layer. That means that when I'm talking about layers, layers in Docker images are also immutable. So once you have that Java layer, it won't change. On top of that layer, you can install any number of microservices that you want, and they will all using the same configuration. As Docker image is built as layers, then if you want to change anything that is below your microservice, you can just change that, rebuild, just copying your microservice, and it's keep working as it was, but you upgrade the whole stack. So somebody can say, okay, yeah, it's fine. It's the same thing as building another virtual image. No, it's not, just because we can reuse the layers. And if we are just changing, let's say the Java layer, or better, let's change just the microservice layer, because we just released a new version. We don't have to upgrade everything. So if you build your service that is, for example, 1 mega, and I will show you a service that is using less space, you can upgrade the whole environment with just sending 1 mega of data to your other machines, to production. So instead of sending a typical application that is using an application server like JBoss or Payara, is probably is for sure going over 3 gig of data. And when you want, if that will be a virtual image, you have to send 3 gig of data around. In this case, you can just send 1 mega around, and we will see how, and that will work, because everything else hasn't changed. And if you want to change the application server layer because you upgrade JBoss, that's fine. You'll have to change to just send some amount of data, not everything. And on top of that, you can still add other stuff. The benefit is that if in your company somebody else is using another Java application and they don't want to know about Docker, they can just use whatever you build and put on top of that, their application. It will still working using the same things. And you can reproduce them any number of times that you want, and it's still working. So the key difference between microservice and an application server is that on top of the application server, you will install your application. That may be larger, but that's fine. So let's see in detail how we build an image. To build an image, Docker uses a file that is called Dockerfile. So how we define the operating system? It's this way. In this case, I start from Ubuntu. So I just literally wrote from Ubuntu 16.04. That means that Docker starts from another image that is being tagged as Ubuntu, named Ubuntu, tagged as 16.04. You may realize that 16.04 is the version. That's fine. Yes?
We are starting from Ubuntu 16.04, but you are running Docker, this Docker image, for instance, I don't know, CentOS or whatever.
Exactly.
It's independent of the operating system.
It's independent.
Running. Okay.
So you can decide whatever you want. That's one of the benefits, because if you, in your machine, for example, are running Ubuntu or CentOS, and in production you have Red Hat, you don't have to build an image on Red Hat, because let's say that you have a package that is only released as DEB. You don't want to go in the mode and build another package just for Red Hat. You can use it. So you have an image that starts from Ubuntu. You install that package that is an Ubuntu dependency with all dependencies that come from with that. And then you ship on Red Hat image, the Red Hat system, and it will work. If it works on your machine, it will work on that machine. So in my case, actually, I'm using a different starting layer just because I made some customization, something that I need, and I'm not going to write every time. So I build another image with some changes, and I named it Daftan OS. It includes everything that I need. When I need a new tool, I just upgrade that image, then we'll change the from other images, and I will build the new images. The process is very, very easy. So I also tagged with the version number, so I know that that version runs on Ubuntu 16.04, and this is the first release, and no patch. I went to that after some time. So at the beginning, I was just using from Ubuntu and doing all the changes. When I consolidated them, then I built that image, and I'm still reusing it. So let's say that we want to install some package. What you usually do is, if you're using Ubuntu, is to upgrade your package dependencies library, and then you may install something. So in this case, we are just installing two packages. What I'm doing at the end is removing the cache of Ubuntu. Yes, you may ask why. Usually you do not do that on your machine. That's because, as I told you before, layers are immutable. So once you store that cache on that layer, it will stay there forever. So you're wasting space. You may not need that cache again. So if you see, I'm also linking all the changes. So for Docker, that is just a single instruction. So Docker is upgrading the library package, it's installing packages, is leading the cache, and also the package cache. So at the end, I have just the two, or in this case, two packages that I want, nothing extra. So from this image to the other one, it's just a couple of mega of difference. So recently, Oracle finally released an official Docker image for Java. Previously, it was not available. You cannot redistribute your image based on Java due to licenses. So what you would like to do is just run apt-get install Java. That's fine. Unfortunately, you couldn't, because due to licenses, you had to accept some things. So you needed an interactive shell, which you do not have in Docker. So what I usually had to do is writing all those stuff to be able to install Java 8. So it's a lot of things. I also had to accept a license. It's not ideal, but that's fine. That was the problem. So what you have to remember that it's not an interactive shell. So if at any point the application or the package that you're installing is going to ask you any dummy question, even if you only have to enter and accept the default answer, it won't work in Docker because it's not interactive. You're running that, Docker is running that for you. So you have to think about all the possible questions. So if you remember, if you see also when I'm installing package, I'm using the -y. That's because I want Ubuntu not to ask anything. I already tested all those stuff, and that's what you have to do. At the beginning, when I was building the image, I was installing package by package by package to be sure that everything was working. It's a tedious process, takes time, but once you did it once, it's going to work every time. So we are avoiding that Ubuntu or your system is asking you any question. So at the end, you may want to do something like that, because your application may point to Java home, that's fine, but that's not just another configuration. If you see all the things that are run in the image, that it's actually bash, are bash commands. The only thing is that we prepend them with the label run. That's because tells Docker, you must run that command. So whatever it is, you must run that command. When we build our image, we can copy our microservice. How? The command is copy. Where is the service? The jar file in our case. And when we want to copy that file, you decide whatever is on the right, and we will see how right means, belongs to the container, to the image. So it's inside Docker, it's not inside your machine. Whatever is on the left, it's on your machine. I will get back to that concept because we will have to do some stuff about that. Yeah. If you're working on an Java Enterprise application, you just have to copy your package somewhere. That may be, I prefer to copy it on OPT, but you can copy in auto-deploy application of your application server or anywhere else, and then you install it. It's up to you. You decide how to do, what to do, and when to do it. So let's see. Let's build an image. When I want to get an image from somewhere in Docker, I just pull that image. There are some places called registry, or repository if you want, but the correct name is registry, that are hosting the images. So when I want Ubuntu 16, I just do run the command, docker pull, and it's downloading the code from somewhere. I'm just running a video now to avoid any latency with the Wi-Fi. At some point, I'm also doing the same for the application that we are going to develop. If you want, I can run that on my computer. It's not a demo that's only working on the video. It's a live application. So if you want, just raise your hand, and I will show you. So we downloaded the Ubuntu 16 application, and if you see, there are 5 layers, because whoever built that image did 5 things. So run 5 commands. They may be aggregated commands, that's fine, but at the end there are 5 layers. So if we want to change anything, for example, on the second from the top layer, we can, and Docker is going to reuse all the underneath layers. That's an advantage because we don't have to rebuild everything, we don't have to ship everything. Now that I have the image in my computer, if somebody else in the company has used that image to build something else, I will only have to download whatever he built. So not again 317 megabyte. And you see, 117, maybe wait for somebody, because Ubuntu, if you're running it, is not using 117 megabyte of your space. That's because usually image have a lot less things that you usually have on your computer. That's why I had to install curl, because it was not there. I needed it. So let's build another image now. Let's run now another image. I spoke to you about registry where we are storing the data. So I want to do the same things. I want to build the images and then store somewhere where my colleagues can use them. So how to do that? I'm just running another command that is docker run. Let's skip what is in the middle, registry :2. That means that I want to run a Docker image called registry version 2 in a container, and I called registry, that's what happens before name, and then I want to run it, have it listening on port 80. So it's on the left. As I said before, what is in the left is happening on my computer. So on my computer, I will have a container that's listening on port 8. But on the right, I have 5,000. That's because whomever built that image set it to run and listen on port 5,000. I don't want it. It's easier to have port 80. So that was my configuration. You may know that typing this stuff in production is not the best option. I would discourage you to do that. Unfortunately, some people are doing that, but that's another story. We will see how to use that, to avoid that, and how to have a lot of services running all together. So actually, you saw to run the registry, it was very quick. To run database, if you're using MySQL, for example, takes more or less the same time. And then you have MySQL running with the default configuration. You can change it in an easy way, but with almost no effort. Somebody else built the image. Maybe they spend months building that image, that's fine, but you just have to do Docker run the name of the image. When I first proposed to the person that could approve to use Docker in the company that I'm working now, he said, no, we don't need it. The application to start that application, it took a lot of time. When I had to upgrade the whole stack or servers of the company, it took 6 months to do that upgrade. I believe that is something that should never happen. To me, something that is over an hour is too much. But that's my opinion. So I went to him second time and said, look, we had the setup bash script that ran some tasks to do. Almost all the time it was working, not every time. And I'm talking in production, not test. So, can you imagine that you say to a customer, oh, yeah, we're going to upgrade your service. It's fine. There may be a couple of hours of downtime, maybe a couple of days that happen. But don't worry, it will work. And then it doesn't work. It's not something that is fine. So I suggest for second time to use Docker. He said no. Then the third time, after some months, I went to him and I said, look, I run a command, Docker run. And I told him, look, here, now I'm running our application in a smooth way. After I've guessed 1 minute at most, he said, yeah, okay, what is next step? That is a web application. I told him, yeah, open your browser. To do what? What we have to do next? Use the application. Application is up and running in 1 minute. How I achieved that? I was using Docker. Nothing special. I didn't invent Docker. So now we want to build a microservice that is using Docker, other services, other things, and we want to have that quickly. So to do that, I usually prefer to use Spring Boot. It's based on Spring, no configuration. It's in some way awesome. You just have to write some little stuff, and it's working. How many of you use Gradle? Okay, luckily I'm not alone. Okay, so Gradle actually is different. How many is using Maven? How many end? Okay, 1. Okay. So our application now is using Gradle, just because I believe that it's more flexible, less hassle, less to maintain, and sometimes it's, if you know Groovy, you can write a lot of stuff just inside your build file, and it's going to work. It's something new to learn. I'm not scared about learning. I would also suggest you to look at Gradle and some of the stuff that we are going to look today. So I'm going to use Spring Boot, and in Gradle, I will have to set some dependencies, those that you see. You can also use that dependencies in Maven. Actually, Gradle is using Maven repository. So whatever is Maven repository is also available on Gradle. If you're already using those dependencies on your computer that are stored on your .m2 directory, those are already available for Gradle. So you don't have to reinvent stuff. You just reuse whatever you have. So we are going to use those packages from Spring Boot, just copy and paste. You may not be interested in what they are doing. We will see how that works. The next thing that I'm using is Logback, because everybody wants to log whatever is happening. I prefer Logback as tool. You can decide whatever you want. Actually, it's just maybe just a matter of personal choice. I believe that Logback is better, but that's my opinion. To deliver XML files, I'm also using Jackson. I don't want to reinvent things. So there is a library that's working, Jackson is working, it's fine. I'm just going to add that dependency. What the application should do, the application should extract some metadata from an image. So how to do that? Luckily, somebody else worked on that and built a library that is called metadata extractor. So just going to use it. It was built on Java, and just use it. How to do that? So in Gradle, I have to define another dependency. You can use that with Maven as well, using Maven syntax. In Gradle, that is what I have to define. So if you can see, they are just not XML, but it's working. How to achieve the tasks is just using controller. So I'm actually mapping metadata in my browser as a request that is doing some things. What is actually doing is to, well, as it is a GET request, I'm just getting the URL. So actually, I'm passing to my application a URL that may be everywhere, and the application will take note of that URL and pass to the library. The library will return in its way with its object and the result, so the metadata list. So the real command that you need to run is this one. So I'm saying image metadata reader is an object from the library, so from the metadata extractor, and I asked it to open that stream. That was the URL. Before that, I had to do some more stuff to clean the URL and figure out other stuff, but at the end, that was the command. I will skip that slide quickly, but I will tell about you. When you're using Gradle at the beginning, they suggest to use the Gradle W, that is a wrapper, W stands for wrapper, that download Gradle if you don't have it on your computer, whatever version of Gradle that the person built the project is working with. So you don't have to worry where I have to download Gradle, what I have to do, how to configure. The wrapper has everything. So if you don't have it, the wrapper is downloading from the internet and then installing. So we will skip that. When we finished, I want to build a project. So that is those are commands that I want to run. So I say Gradle clean build. Like I said, everybody can understand that. And then I want to build the image on Docker. How to do that? Docker build. Then I'm using the -t, that means tag, and the name of the image and the version number. I suggest you to, of course, to increase the version number every time. Then I'm running the application. So I'm mapping port 80, because in my application I said that is listening on port 80, on port 8080, because maybe this is a production server, and I'm running something else on port 80. This is a microservice. I want it to run on another port. That's fine. You can change it to whatever you want. So I just did it. When it's running, but this is Gradle compiling the application. At the beginning, the first time, Gradle takes some time to build the application. Gradle has a system that is a daemon that is running on the background. So from the second time that you are running the script, it's much quicker. Usually, it goes down from 2 seconds to half second or 300 milliseconds. So it's much better. Now it's Docker building the image. So you see, any line that you see as a step, it's a step, is a command that I wrote in my Dockerfile. So now the application is running. This is Spring Boot configuring some stuff. So we can just go and pick an image and have it running. To build that application, to put all together, it took me 2 hours. When we first spoke in the company to build it, they planned 8 weeks to do all the job. So after 2 hours, nobody believed me that it was ready. So let's pick an image. I will use the image in the middle. And if I want to get the XML version, the JSON version, I will just have to pass the URL into the browser. And this is the output that I get from the application. If you saw, I wrote almost nothing in my application. Really, really few things. Of course, those comes from a library, but that's fine. We don't have to reinvent the wheel, or maybe somebody else in your company has built it. This is the XML. That's why I added JSON. Otherwise, I couldn't have it. So how to prove that the application is working? I usually use Spock. That is a tool for testing in Java. It's built on Groovy, but you can use Java as you do. I believe that it's awesome. I suggest you to have a look. So let's look at the Dockerfile, actually. The same that I ran for the microservice. So from an image, in this case it's Java, That means that there are many more underneath. But at the end, I need Java to run my application. So I'm starting from Java latest. It's my latest, it's not Oracle latest. Then the maintainer, so whom to have to go to if something is broken. So it's also taking the responsibility. I'm exposing port 80. That means to Docker, the application is listening on port 80. So Docker is making available port 80 to everybody. Those two commands actually say to Docker what you have to do when you're running that application. So you're running command Java with parameters -jar metadata.jar. So that's actually the core of what you need to do. Of course, where is your metadata jar? You have to tell Docker where is it. So on my machine, it's called metadata-100, and I'm calling it /metadata.jar into Docker. That's enough. That's all. You don't have to do anything else to have it running. So when you run it, you say, oh, okay, cool. It's running, everything. It's running on my machine, so as I told you, it's going to run everywhere. So we moved that on a server, and I was just sitting there saying, oh, yeah, it's going to work, cool. It wasn't working. So I said, okay, well, it must work. It was working on my machine. So am I lying about everything else? No, I wasn't lying. We spent some time. I did a lot of tests. I tried on different machines. It was working on most of the machine, not on some. So I said, come on, it's impossible. It must work. So we went back and checking everything. And at some point, somebody said, oh, it was a sysadmin. Say, oh, we didn't attach the network cable to the server. I said, oh, no, come on. You are joking me because it's not possible. Yeah, that is. Now we plugged the cable, and suddenly it was working. So I said, okay, come on. At the end, we decided that we are telling to our sysadmin, to ask them, have you connected the cable? It's unbelievable. Then actually, we found out that they decide to use a different strategy for Docker. We want to have things doing in a cool way, so they use whatever I was working on to improve the company quality of network, the systems. So they decide to use vLANs. That's a cool thing, so you can segregate your applications into different environments without having to work a lot with the firewall for every instance. So they used vLANs, that's cool. We are going to use vLANs, that's cool. No, because vLANs are an experimental feature in Docker, so you actually have to tell Docker, look, you must use an experimental feature. You may be scared about using experimental features, but you may see the Leaning Tower is still there. It was not something that, it was mostly an experiment. It's still there, so maybe it's working. Actually, that experimental feature of Docker is still working in our production. So how to do that? You have to set in your Docker host, so the host that is running Docker, into the file etc docker daemon.json that you want to use enable experimental feature. Once you do that, that's fine. You can use all the features that you want. So I'm not spending a lot of time with orchestration, but when you are running one microservice, you want to run many. You want to have something that may work for you. So if some service go down, it must be live somewhere else. So that happens with the orchestration. There is not enough time to look the orchestrators, but actually you will need a conductor that will drive all the stuff. There are 3 systems at the moment. It is Swarm, Kubernetes, and Mesos. I can't suggest any of them. If you just want to start and having things working, look at Swarm. It starts very quickly. If you have other needs, you may want to look at something else. Very, very quickly, those are the usage this moment. So most of people are using Kubernetes. Most of the company are switching to Docker or realize that they're going to use Docker. And them are planning to spend this year $500,000 only for Docker. What I want to say is that you must be part in your company. So don't worry about trying and experimenting and pushing. May take time. Sometimes somebody can forget the cable, but keep trying and you can make it. Any question? Yeah.
What's the minimum requirement for running Java with Spring Boot in
Yeah, so the question is how much RAM you need to run all the services on using Java. That depends on your application. Of course, Java is using a lot of RAM, a lot of memory, so you need to plan that ahead. What you are avoiding is the overhead of your operating system. So if you're using a lot, your application is using a lot of CPU, a lot of memory, you will need a machine that has a lot of memory. On the orchestrator, managed how much instances can run on the same bare metal, so they will optimizing your infrastructure. You're not wasting space for other operating systems. You can use all the remaining memory for your systems. And the orchestrator will just fire another instance or close another instance if there is not enough memory or needs more of them. So there is not a clear answer, I know, but that depends on your system. Another question? Yes? Not at the moment, just because kernel is using, as it's built now, Docker, it needs to use a Linux kernel, so it doesn't work. I read that Microsoft is working at something like that, so they may have something soon, but it's not yet available, unfortunately. Okay, can I have time for another question? Yes, last one.
Would you use Docker during development or only production?
Everywhere. Honestly, I also use Jenkins in Docker on my machine, another machine in development environment. The benefit is that sometimes for Jira, for example, they are producing a Docker image. So when you want to upgrade, you just pull a new image and everything is done. You don't have to configure, change, put in configuration. For Jira, you just have to apply the license, and that's all. Okay? Thank you very much.